Hey guys, welcome back to our journey into Python programming. I know my pickup line has been quite old now, but hold on for some more new sections. So, in this new section, we are going to start with inheritance. If you are from bio, or if you have a bio base, or probably you are from a science background, then you must have heard about the word inheritance. So, for people who don't know, in biological terms, inheritance means passing of one trait to another. So, passing of one trait from one generation to another generation. Let's say your father has white hair. So, everybody has white hair. Let's take blue eyes. So, your father has blue eyes. So, it's a probable chance that you will be also having an blue eye. Okay. So what is this? This is passing of traits. What are traits? Traits are qualities. Passing of qualities from one generation to other generation is known as inheritance. So the passing of blue eyes from your father's generation to your generation is known as inheritance. That is in biological terms. Now we are going to look into what exactly do I mean by inheritance in Python or any other programming language. To be very fair, all of these concepts are quite similar in each and every programming language, but the way you execute them is quite different. So, inheritance is the capability of one class to derive or inherit the properties of another class. The benefits of inheritance are this. So, what I mean by this is, let's say one class, we have a parent class. In one class, we have three methods, and you have a child class. That child class is inherited from the parent class. So, all the three methods that the parent class is having, the child class will be having them also. So often came across different products that have a basic model and an advanced model with added features over and above basic model. A software modeling approach of OOPS enable extending the capability of an existing class to build a new class. Instead of building from scratch, in OOP terminology, this characteristics is called inheritance. The existing class is called as base class or parent class, while the new class is called as child or subclass. Inheritance comes into picture when a new class possesses the is a relationship, if you have heard about, with an existing class. Like dog is an animal. So both are two classes, dogs and animal. So they are dog is inherited from the class animal. Cat also is an animal. Hence, animal is the base class while dog and cat are inherited class. Again, let's say we have two classes, dog animal and cat. Okay, cat animal. So, animal is the base class and dog and cat are the child classes or derived classes. Let's take one more example. A quadrilateral has four sides. A rectangle is a quadrilateral and so is a square. So quadrilateral is a base class while rectangle, square are the inherited classes, also known as the child classes. The child class inherits data definition and methods from the parent class. The facilities, the use of feature already available. The child class can add a few more definition or redefine a base class method. So other than what a parent class is having, other than the methods that the parent class is having, a child class can have extra classes of its extra methods of its own or extra data members. Okay. So now let's look into the syntax of it. So while defining the class, let's turn on the marker. Okay. So class, base class, body of a class, body of the base class. Okay, I guess yeah, this one should be over here. So that is class derived class. So let's have a line break over here. I guess by presentation it has just gone wrong. It is class derived class and then the base class, then body of the base class, body of the derived class. While defining the child class, the name of the parent class is put in parenthesis. If you could like this, indicating the relation between the two instances, attributes, and methods defined in the parent class will be inherited by the object of a child class. A quadrilateral class having four sides as instances as variable and a perimeter method. Okay, let's take, we have a quad class and in that we have a perimeter, and then let's define a new class. Okay. Class square, and if it is inherited from that class, then all the methods, that is the perimeter method, can be called out from class square also. So that's how useful this inheritance can get up to. So let's look into exactly one more example of it. So we have a class animal, and inside of this class animal we have def speak, that is a class method, and it is printing animal speaking. Okay, so I have a method over here that whenever called will just print out animal speaking. Then I have a class dog, and inside of brackets I have written animal. So what is the parent class over here? Animal is the parent class and dog is the child class. Inside of dog we have one more new method of itself, that is bark, which will print out dog barking. And then what exactly I'm doing it? I am defining an object for the class dog, as dog is inherited from animal. So if I call d dot bark, it will just say dog barking, which is already a method of this particular class. But if I say d dot speak, which is a method, if you could see, which is a method of animal class, it will be also displayed of. So a child class can use all the members, all the methods, all the data members of the parent class. Along with it can also have new properties of its own. So the output is quite like this. So first it's d dot bark, that is dog barking, and d dot speak, that is animal speaking. So that's it for the definition part of inheritance. Let's jump into a Jupyter notebook in our next video, and let's look into some of the interesting problems that we have in this.